and welcome back to Pre-Calculus Honors.
So at -2, we're at, here very, very close. Yeah. Oh, I didn't do that.
Wait, also for
So this is e to the 2, hang on, and this is e to the 4. So, CU, so this is 7.4, and how much? Okay. Now, first we're going to graph e to the 2x for which the asymptote is y equals 0. All right? So here we're at 0.14, and then we're at 1, and then we're at 7.4. So here. This is e to the 2x. Next, I'm going to translate it up. So everything is going to move up 3 spaces, including the asymptote. Okay, so this is the new asymptote, y equals 3. Everything here moves up 3 points. So here, this one goes up to 4, and that's going to move up 3 points, right, to forever. So it's going to look like this. This one is e to the 2x plus 3. Now, the domain is -infinity to +infinity. The range is what? 3 to infinity. Again, without a calculator, you should be able to know that, even if you don't see the graph. As x approaches -infinity, y is 3. And here we're at +infinity. It's continuous on all real numbers. Okay, now for some applications for growth and decay. One is compound interest. So you take your money to the bank, you put it in a bank account, and it accrues interest. There's simple interest, meaning, at the end of 5 years, if it was 5%, they just, calculate it and they, give you a lump sum. Compound interest is when throughout the term, you're being paid money. And depending on, the type of product, type of bank account, you get paid either monthly or quarterly or annually, okay? All right. So what we have here is the formula for compound interest. And P stands for the principal, which is how much money you go to the bank with. R is the rate. N is how many times interest is compounded. So if the bank pays you interest monthly, N is 12. If the bank pays you interest quarterly, what is N? 4. And A is the balance. A is the balance. Quarterly is 4. A is the balance. Basically, it's how much money you have on the statement, right? When the statement arrives, that's how much money you have in the bank. T is yours. Let's solve a problem with it. Alright, so this person invests $2,000 into an educational account for her daughter when she was an infant. The account has a 5% interest rate. If she does not make any other deposits or withdrawals, what will the account balance be after 18 years if the interest is compounded quarterly or daily? So let's write down the given. 2,000 is the principal. The interest rate is 5%, which is 0.05. T is time, so T is 18 years. And what we want is A. Now, we want A, the balance. For part A, money is paid quarterly, meaning N is equal to 4. 4 quarters, N is equal to 4. So we plug it into the formula. A is equal to P, 1 plus R over N to the power of NT. Meaning, this is 2,000, 1 plus 0.05 over 4 to the power of NT is 4 times 18. Okay? And this is going to be plugged into the calculator. So let's do that now. So what we have is 2,000 times 1 plus 0.05 to the power of 4. It sort of looks like that E formula, doesn't it? To the power of 4 times 18. Okay? Enter. $4,891.84. I will not tell you to round to the second decimal place. You should know that when you're talking about money, you need to round to the second decimal place. Okay? And there's a dollar sign. Okay, so this person invested this money, $2,000, and now it's been 18 years. So it makes sense that it's almost doubled. It's 2.5 times as much. Okay? Watch out for answers that don't make sense. For example, when your money decreases, when you're, up to the, however many $billion, okay? Watch out for this stuff. Okay, so part B, N is now what? If it's daily, N is 365. So A is equal to 2,000, 1 plus 0.05 to the power of to the power of 365 to the power of 365 times 18. And when I go back to my calculator, I do second entry, and now I just go and edit. So the 4 is going to be 365. What happened? 365 times 18. And here, I'm going to delete this one, and I'm going to put in 365. So I get $4,918. So what happened? In the one case, the bank was paying her interest 4 times a year, and she got $4,891, and then now they're paying her interest every single day. And how much more money does she have after the 18 years?
$20.
It's barely like $30. Okay? Right. So why? Okay, why? Because as this number goes to infinity, what's supposed to happen? It's supposed to level off. So it doesn't matter. Knock yourself out, right? The bank could say, hey, look at this. Like, we're just fooling these people, right? Because they don't know. The bank is like, hey, we'll pay you interest 3 times a day. That's like 365 times 3. But still, at the end of the day, there's a maximum, there's a cap. They're never going to pay them more than that. Okay? Right. Because as long as, it all depends on this. Like, there is a cap, and it can't go over that. Well, $20 more if it was in that bank account where you would get paid daily. Okay?
Still made like $2,500.
Okay, so what if now the bank says, hey, you know what? Forget it. Forget this daily business. Forget this 3 times a day business. We're going to pay you continuously. So our computer is just going to be set to pay you every single nanosecond. Every single nanosecond, it'll figure out how much interest and pay you. So now that number n, it's not 365, it's infinity, right? That number n is now infinity. But what happens when n does become infinity? It's just going to level off. So what ends up happening is, if the bank pays you interest continuously, okay, then this is how much you're getting paid. Why? Because remember what I was saying before? Hey, this looks just like that other formula. So because it is r over n to the power of nt. Remember what the other formula was? 1 plus 1 over x to the power of x, right? So look, this, okay, if that, as n approaches infinity, it levels off. So it becomes e. Okay, so it becomes PE to the RT. And I call this the Purdy formula. Right, so now Mrs. Salzman found an account that will pay 5% interest compounded continuously on her $2,000. So she said, hey, I'm going to put it in that account and I'm going to make millions. Okay, so let's see. R is 0.05. So A is 2,000. E to the power of 0.05 times 18. How much is that?
It is 4,919.
Oh.
Point what? 0.21. So she's made 31 cents. That's right.
You know what you can buy with 31 cents?
More than I thought. You came and buy 30.
Wait, Sarah just made the joke of the year. I said she has to throw a party.
Welcome back.
So investments are one case where we use exponential growth and decay. More often, we use them in population growth, we use it in radioactive decay, and so on and so forth. In this case, the theory is the same. The equations are basically the same, but they're sort of modified. So when you have exponential growth or decay, this is what we use. Okay? And in the case of continuous exponential growth or decay, we use this. Now, I am conflicted between, with using these formulas because the book sort of has it differently from what we usually see them as. So this formula usually is written as y equals either a naught e to the kt or y equals y naught e to the kt. Okay? Your book uses n. They're all the same. N or y is the amount that you end up with. Okay? So this is the final amount. This is the initial amount. All right, and it's the same thing here. A naught is the initial amount, y naught is the initial amount. And in this case, it's usually, y is equal to y naught, 1 plus r to the t. Now, this is important. If r is growth, then r is greater than 0. For decay, r is negative. Okay? Same thing here. Continuous growth, K is positive. Continuous decay, K is negative. Okay? Do we have to memorize these formulas? Yes, we do.
Yeah.
Just write that down. So you remember.
Okay? All right. A state's population is declining at a rate of 2.6% annually. Okay? So here we have a rate, and it's declining. The state currently has a population of approximately 11 million people. If the population continues to decline at this rate, predict the population in the state in 15 years. So what do we have here? I have R, but it's declining, so it's negative 0.026. I have a current population, Y0, of 11 million. If the population continues to decline, I have time, 15 years. What I want is Y. This is not continuous, right? It's declining at an annual rate. So this is what we're going to use, the first one, okay? So if something is declining annually, this is what we use. Y is equal to Y0, 1 plus R to the power of T. Y is equal to just 11, not 11 million. 1 minus 0.026 to the power of 15. Hang on. What's 1 minus 0.026? 0.974. Because it's 0.026. So this is important to write it this way. Okay, sometimes they will ask you for the model. I'll talk about that in a minute. So it'll be how many? What's the final answer?
7,409,297.
So it was 7.409 million. And I'm fine with that. Okay? Yes. Okay, so sometimes what they ask you is for the model. The model. When you're asked for the model, this is what you should write. Y equals 11 to the times 0.974 to the power of T. Okay? Because then you can graph that model and you can do all sorts of things with it. Okay? So this is it. This homework will be due tomorrow. Friday.
And then, are we also training?